resistance here, and similar to that there should be correction in the next circuit also. So in this high pass circuit we use capacitance then resistance. Okay, but now we have this question. So this is an inverting amplifier. So the gain will be minus of R2 upon R1 plus SC, isn't it? This the impedance of this will be 1 upon SC. So this will be R1 plus 1 upon SC, isn't it? So this like this the gain will be like this. So this can be written as minus of R2 upon R1 plus 1 upon omega G omega C. Yes, correct from here. This one is correct. This is the gain. Okay, so actually the mode of gain will be equal to R2 upon root over R1 square plus 1 upon omega square C square. So when omega equal to 0, then this will be 1 upon 0, this is infinite. So this term, this is 1 upon 0, this is infinite, this is R1 square plus infinite. So if you add something to infinite, this will be infinite, and 1 R2 upon infinite is 0. So mod of A will be equal to 0. When omega equal to 0, mod of A will be equal to 0. Case 2, when omega equal to infinite, then mod of A equal, when omega equal to infinite, then 1 upon omega equal to 0. So R1 square plus 0 equal to R1 square, then gain will be equal to R2 upon R1. That means at 0 there is 0, at infinite there is a constant value, that value is equal to R2 by R1. This is the gain. At cutoff frequency, when omega, what will be the cutoff frequency? For determining cutoff frequency, you have to take R1 out of this. If I take R1 out of this, this will be 1 plus C square R1 square. So cutoff frequency will be equal to R2 by R1 divided by root 2, that is equal to, when this one equal to 1, so this will be omega C will be equal to this, this value will be equal to 1 upon R1C. So when omega equal to 1 upon R1C, then this will be gain divided by root 2. So this, in this way, this is again a high pass filter. Okay, so we have done a mistake in the previous circuit. You just correct this. There should be capacitance here and resistance here. Also there will be capacitance here and resistance here. Make corrections. Then if you do suitable analysis, here here also you should put omega equal to 0 instead of omega C, and omega equal to 0, then you will see the correct, get the correct result. So change the our analysis according to that. Okay. So this circuit is a high pass filter. So if you get this circuit, don't get confused with the circuits. Just do analysis and find out whether this circuit is a low pass, whether this circuit is high pass, or whether this is a band pass filter. Again, I am giving a question to you, next question, in which you have answers, 4 answers. whether this is a low pass, this is a high pass, band stop. So determine, and the problem is determine the type of filter shown in the figure below. You have a figure in which there are two capacitances like this, plus terminal is connected like this. There is a resistance R2, here is a resistance R1. After C2 there is a resistance R3, and between C1 and C2 there is a resistance R4. This is actually second order circuit of high pass filter. I am telling you, just you can do the analysis, and after मुझे पता है कि क्लास है. Next, then after doing analysis, you will get the gain AV equal to 1 plus R2 by R1 for this inverting kind, or the frequency, cutoff frequency for this, the gain of this. This is the gain of this. Because this is not directly connected here, this feedback is this one is not connected directly here, therefore we are not considering that as a feedback. Okay, so I am considering this as an important feedback, and the gain will be 1 plus R2 by R1, and the cutoff frequency is equal to 1 upon 2 pi root over R3 R4 C1 C2. Okay, so this is the cutoff frequency of this second order filter. Okay, so I am just turning on your attendance. Just wait for 2 minutes. Okay, so let me tell you about the advantages of cascading. Usually in this graph of frequency response, this is also called Bode plot, there is a roll off of 20 dB per decade in a first order circuit. So when you go to the second order like this is the second order circuit. So if you go to the second order like this, then what happens, this will be more steeper. This will be around at as a 40 dB. If you reach second order, this will be 40 dB per decade. Okay, so roll off changes. So that is the advantage of cascading if you do the cascading. So this is second order. If I add this first order and the second order together, if I connect first order circuit then second order filter, and then what will happen, the resultant will be so sharp, means it will get so sharp transition that the resultant will be 60 dB per decade. Okay, so that's how this is the cascading of filters. Okay. Okay, thank you so much. Now the class is over. You can go for the another class.